Hey everybody, it's Nick. I got a continuation of the earlier tutorial we did on transformation and repetition. If you remember, we go back to the lab, slides. We're looking at transformations, right? Which is, move, rotate, and scale. And we've seen some examples in architecture, and this example actually does all three, as we said. You have this floor plate that gets moved, in the z-axis, and it gets rotated and then it begins to taper, in scale as it goes to the top, right? And we've seen some examples. We started off with move. That's what we got through in class, right? Just simply taking something and like repeating it in a specific, kind of way. Uh, and we also talked about like, how powerful it is to make, copies of things using the move tool, right? Every time we have a transformation in Rhino, or we have an additional input, right? The system makes a copy. And we talked about how numbers depending on the number of times you do something or the number of inputs you have, right, um, you can get different kinds of effects. And then we talked about basically a little bit about how to break some of these things down. So like, for example, like, in this piece right here, um, you're looking at these circles, you're looking at these arcs, in the circles. You could actually do it just with the circle command itself. So if you have just a circle, I'm going to go back to just not full names. And I'm going in the top view for all these examples here. So just to recap, right? If we have a radius for something, right, for the circle, you could just do a series component. Remember, a series is something where we take a starting number and we're going to add some value to it, and we're going to do it a certain number of times. And so if you just simply plug it in for the radius, right, you have 10 inputs, you're going to get 10 circles. And that first circle, look at that. Actually, let's go to the panel component. That first circle is invalid, right? And that's because the radius is 0. So you got to be careful of the inputs too. We've talked about that a few times as well. So, we could go in and say like the starting number, maybe wants to be 1. Okay, now it's fine, right? It's happy. As long as it's not 0. And we can put some number sliders in, and we can change that, right? And then of course like it's pretty easy. Like at that point, if we take that collection of things, and if we plug it in for the geometry, right, we can move it, in the x-axis, and we can put in a number slider, go to hundo, and bring it back. We can start to get into that effect. Of course, we have to like design the effect for what we want, but we can experiment with that because it's parametric, right? But this illustrates two things. One is that, here we have a list of 10 numbers. We got 10 circles. Here we have one move command, right? And we moved these things with one move, and so they all those things got translated the same. If we had a series component and we plugged it in instead, uh, then we actually are going to move each one a different amount. Okay, because we have 10 circles and we have 10 transformations, 10 vectors. And I'm going to be a good teacher here and put a panel in, right? So 10 things getting moved 10 times gives us this effect, which is pretty cool too. Okay, so that's a little recap of what we did last time. We're going to go ahead though, and you go back to the like rotate tool. Okay, and I covered this a little bit, but I did it pretty quickly last time. So just to go through again, I'm going to go ahead and just do something like an ellipse. As an ellipse is actually something that has, it has a starting point and it has a first radius and it has a second radius. And I'm just gonna, for now, I'm gonna drop a couple of number sliders in here so you can see what the result is. So that's what we consider radius 2, and this is what we consider radius 1, right? So you don't want them to be the same. But something to note, when I do this kind of thing, right, is kind of take one of these things and just kind of make one. That's just, I'm doing copy paste. So that's Control C, Control V. Okay. I kind of do that without even thinking. And this little grid that shows up, that's just a plane. In class, all I've done with these, at least, is just put them in a curve, and then I don't have to look at that thing because it kind of gets annoying. Okay. So so rotate. So the rotate, there's different there's a 3D rotate, but we're just gonna look at the like 2D rotate. And the 2D rotate starts off, it has the geometry, it has an angle, and it has a plane. And right now the plane is XY, and that's fine. I don't need to change that at all. The geometry is going to be the curve, and then the angle is in radians. And I don't like to use radians, so you can do two things. You can use a radians component, and then you can, oops, and then you can create a number slider for it. And I did this, I like to just use 0, 180, 360. And that gives you the full rotation for an object. Oops, I don't want a robot. 0, 180, 360. And that gives you, that's going to give you the full range of motion for these kinds of things. If you wanted to move something more than that, you could always multiply the output by some number to get, multiple spins, but that you don't need to worry about that. Oh, and then once again, I'll just do this so I don't have to make another component there. Now I don't have to, I don't like those grids. They really get in the way. I'm not sure why Rhino does that. The other thing you can do, because people that know Grasshopper pretty well are going to yell at me right now, but you can use this component. You can also you can go right click and you can say degrees. And then you can it's just going to let you use degrees. And that might be cleaner, but you have to make sure that that's working, that you're actually using that. And the radians thing is pretty clear. So that's how we use rotate. And then, once again, we can take something, like a series component or let's do range component. Remember, range component takes some number and divides it by a number of steps. And so I might take this in and I might let's see, and I'm gonna do a construct domain. A domain is just a range from some number A to some number B. That's it. Okay. And I'm gonna go ahead and use this for that. So now what I've got is, let's panelize this again. I will have 10 numbers and it'll be divided. So I can say like, I want to think from 0 to, 90. And it's divided 10 times. Pretty cool. Remember, you got 11 things. You start at 0 and go to the 10th thing. So you actually have 11 things, but that's okay. There you go. Right? Ooh, it's like an atomic thing. Yep. So 0 to 180 divided, 10 times. Okay. So that's how, rotate works. Do a couple things here. So that's a basic kind of rotation script. One of the things I showed you before was some grids of things, and I didn't really talk about like how to do like a grid. And so I want to explain that. There's lots of ways to do it, as we'll find out in class. There's lots of ways to do many things in Grasshopper. The easiest thing I can show you right now for making a grid is to go into the vector components and then just use one of the grid components. And I would say you could use a square grid, or there's lots of different ones. So like for example, I could take this triangular grid, and it's got a base plane, size of the edges, number of grids in the x and the y. And you can do some pretty neat things with these. This is really basic, but I don't know. Anyway, so there's that grid. You can also do a just a regular kind of square grid, like you'd expect. Okay, same difference. And grids give you points, right? And they give you cell outlines and stuff like that. The points are what we kind of want, and I'm just going to pipe them into a point container just to kind of illustrate what these things are. All right, let's go ahead and hide these here. these out of the way. So if you look at these, oh, the points at the centers. Ooh, I don't want that. Okay, well anyway, those are points at the centers. It's not quite. Hang on a second. Not quite what I wanted. Okay, well, let's just work what we've got. So if you've got a point, a lot of times you can take something like you can take an object and a point will work for a plane, in this view. So you can make circles at each of the points, and then you can control them as you would, as we've been doing. They're very big right now, so anyway, got to make these. Wow, they're very big. Let's just do that. And of course you can hide these things. So that's one way to get some of these things right, is to say like, okay, I have a system for distributing these things, right? That's going to give me points. You can kind of play with that. You can also play, with different inputs and that kind of stuff. The other thing you can do with a grid. So here's all these on this grid, right? We can go ahead and use that, for now. So that's actually something I don't probably want. Let me go ahead and grab my ellipse from before. Circles don't rotate very well because they just look like circles. And that's not cool. That's not interesting. It's probably cool. Let's see here. How big are these things? Oh, I hid this, so I can't see it anyway. Aha! All right. Let's make these a little. Let's make these. Oops. Let's make these. Here we go. Real numbers, so we can make them really, really small. Now, obviously, the scale that I'm, working with these things at is not, it's not very large. Okay. So I've got all these ellipses. Now, now we'll try to rotate them. I'll just show you. I'll show you something. So we got rotate. So we're just gonna take our geometry and we're gonna take and this is where the plane, matters, in terms of, when you have something. Actually, I suppose I should go back. When you have something, in this case, it was at 0, 0, which is the world location. But really, what you want is the centroid of it, and I showed you how to do that with the area component. I'll just show you what that looks like there. Let's hide this. Sorry, a little confusing here. You have an ellipse. The area will give you the C, which is C is the centroid, and that is 0, 0, 0, and that's what that dot is right there. You can do the same thing here. So these are all, oops, not enable. These are all the ellipses, and then if I do an area component now, hang on a second here. Yeah, so there's all the centers at each one. You plug that in for P. Otherwise, as you saw, if I don't have that, oops, that actually doesn't work. Then they are all rotating about the XY, and so all of these are rotating this way. Let me show you what that looks like. Radians. Actually, just grab. It's always handy to use things that you've already made. Try not to redo things if you don't have to. You can also copy paste things from other scripts if you've got them. So this is what this looks like. You can see like they're all rotating around. That's what they're supposed to do, because that's what you told them. They're all rotating around one point. And that's all the information they have. It's one point, one rotation. So everything in the list, all 25 of them are rotating. So what you can do is instead is you take the centroid of each one and you plug it in for P, and then you get a behavior that looks more like what you probably expect. Ooh. Now the question is though, is like, how do I get these all to rotate like differently? If we've seen some examples in these of these kinds of things, right? Where they're rotating, they're tumbling or something like that. Okay. So if I go back, I think it'd probably be handy to do a range, and we don't want to do that. Let's do a range. Actually, I probably already did this. Once again, yeah. So just grab grab all these here. I don't need all that. Okay, so instead of plugging in this one thing, I can plug in multiple things, right? Okay, now some stuff's happening. There's actually two things happening. One, remember, the number of items matters. So right now, you get the rotation, but we only have 10 rotations. Well, we actually have 25. Well, we have 30 things. What am I talking about? I have 30 things. So that's an issue, right? So if you wanna match, well, so like a couple things. Also, you'll notice that all these things are like dashed lines. Anytime you've got that, and we'll talk about this a lot later, but just bear with me for now. You have a data structure. So you can look at it and say, so it says it's basically 6 lists of 5 things. Uh, yeah. So it's each of these rows has like 5 things. You can see this like so there's these 5 things, these 5 things, these 5. It's just the way that this component organizes this like grid component organizes things. It says points as tree, so I don't like that. Um, what we can do with that though is instead of having that be um, organized that way, which we'll talk about, we can do what's called flattening. And when you flatten something, let me take a panel here. So this was the list before, and now this is the list afterwards. So you can say like this one has these groups. You know, there's 5 groups, 6 groups. Sorry, 6 groups of 5. Um, this is when you flatten something, right? It just destroys that. It's just now it's like 30 things, which frankly is what I want most of the time. So now I've got 30 things, but at the same time, I've only got 10. You know, I'm only tumbling these things 10 times, right? Um, and once I run out, it just repeats that. That's actually not even applying a transform. Let's look at the panel. Well, yeah, that's what's coming out of it. I guess it's not going to show me the so anyway, but once it runs out, it's just gonna keep the same thing going. That last one's gonna repeat itself. So we need to match the number of things. So one way to do this is with a list length, and what it is basically says how many things do we have, and you can get it you can get it from the number of points. You know, anywhere you see how this is dashed line, that means that it's got this data structure. That means that that's in these 5, 6 groups. When everything's flattened, there's no structure. It's just a clean line. It's not a dashed line. Okay. And so we can take one of those things, and all we need is the number of things. And all this does is just say, okay, we've got 30 points. Great, 30. Just how many things are there? And we can plug that in for this. And then that way it doesn't, no matter how many like things we have, it's always going to adjust to it. It's always going to know. We can plug these both in. If you wanted a square, just plug them both in. You don't have to worry about it. You get 100. 360. Um, but you can see we got a little problem, or if you notice, there's an extra one. And this is where I said, our list has 121 things, but we get 122 from here, just because of the way range works. So this is where you just do x minus 1, and then that goes away. That's it, just a bug. And then this is where you could have some, if you wanted to have things rotate a multiple number of times. Like I said, you can just add a multiply to it. And you can start to get some really interesting things. So that's 1 rotation, 2 rotations, 3 rotations. Pretty neat. So you got a system to play with. So, you could easily make this, right, at this point. You could also say too, like, these things are not, in this case, maybe they're not rotating like all the way. Maybe they're rotating they according to a sine wave or something like that. We've already talked about that. But that illustrates a couple of points. I mean, one, so like, getting something with a grid is a really good way of getting points to distribute objects. And then two, got this idea about sometimes you get these things that are in data structures, and like how do you get them so that you can actually talk to each thing separately as opposed to in these groups, because a lot right now you're not interested in that. And that's what the list length component that tells you how many things you have, and again, matching up the number of things that we need. That's stuff that's really important. That's gonna cause bugs for you. um let's go ahead and hide all this for now. Just really quick, so like, I'm not very satisfied with the center. Actually, this one's on the grid corners. Oh, well, that's nice. Okay, never mind then. This one's on the grid centers. Boo. We'll talk about breaking that down later. Anyway, so this one is fine. This one gives you the things at the corners, and I'm gonna call that good enough. Um, so yeah, so that's one way to get things. Another thing, just to kind of throw something else at you. If you had some kind of an object and you wanted to put it at all these different things, like we saw in this example here, you can do that. So this thing is not a Rhino, it's not a Grasshopper object. It does not have, it doesn't have any parameters, right? So if we take a curve and we put it inside of the container, there's nothing to really do with it. How do we get that to go to all these different spots? Um, so the way you do it is there's two ways. Well, no, there's one way. um, you can go ahead and find the area component of it. Oh no, you can't, because it's not closed. So what do you do? So if you have a closed thing, you can find the area. That's not bad. So what you could do with this is, I need to find polygon area or polyline. Hang on one second. I'm trying to find the easiest way to do it for you, because there's lots of ways to do it. Find the center point average for a polyline. Yeah, let's do that. Oop, doesn't like me either. Cannot convert input curve to polyline. Oh, that's a okay. So let's see, curve center. I don't know if it's gonna let me do that or not. Here, one second. Control polygon. Let's see. I know a way to do it, but I don't want to give you guys something tough. Right. And that is the control points. Nah, we could average that. Here's what I would do. To get what you want, I would do I would do a bounding box. And a bounding box is just draws a box around the object you've made. And then I would find the area of that. There you go. And you just hide all this stuff. You just pretend like it doesn't exist. There you go. Close enough. You could also like draw a point or something on it and use it as your reference, but we're just going to do this. And then the last thing that we're going to use is the orient component. And we'll see this a lot more, but basically it just says like, take some geometry, some object, and wherever it comes from, that's A, and place it at B. And in this case, I'm just going to do this so it's clean. So here's our grid. Getting messy with my thing here. And plug in for B, and that's it, basically. Okay, then you can hide these. wonder why all these things have. Oh, because the points are here. Yeah, same thing. Anyway, you can get any geometry that you want to a location if you use this method. This is what the orient method gets you. Okay. And so we just have a bunch of points and we have a bunch of geometry that we found a point on that geometry and we say take that geometry with its point, whatever we decided was its point, and distribute it to all these other points. All right, and this is probably as good a time as any to talk about scale. So we've already got these things. Let's go ahead and hide these for now. We'll go ahead and turn back on. We'll go ahead and keep this. All right, so I'm gonna get these points, and I'm gonna go ahead and make a rectangle. And I kind of complained about this before, but the way the rectangle works is actually a series of domains. It's not the way you think it is, like where you're you're giving it a width and a length. It's like it's got these two dimensions that are actually like domains, and so that's something we have to kind of deal with. So we'll go back to construct domain, and this is a kind of a pattern that I've used to make these things. And so you make like a number slider. Let's see here, number. Let's do this. I don't know how big these are going to be. That's actually part of the game. I'll just make them 1. So you plug it in for this and for this, and then what you do is you can just say -x, and then that actually allows you to oh, did it not make it real? Oh wow. Anyway, oh that's why. Anyway, so it allows you to make that dimension. So now it works sort of like the way you'd expect it to, except you have to think about it as double. So think about this as the radius. So whatever this value is in this case is actually like the radius of it because it's drawing from the center. Which again I don't really care for. We can change that with some math and stuff, but I just want to sort of point that out. So that's how this works. If you want to just make a square, you can just plug the same thing in for x and y, and then that's going to give you squares. That's the rectangle component. Again, I'm not a fan, but we use it a lot. There isn't really like a square component or anything like that. That's just the way the rectangles really are. There's some other tools that work differently, but this is what's built in. So anyway, we've got all these squares. I'm gonna do the scale component. So the scale component, this is uniform scale. There's different kinds of scale. We're not going to get into that right now because I've already talked for a long time, but basically the way it works is you have geometry, you have a centroid, and you have the scaling factor. And like I said on Thursday, the scaling factor you can think of as a percentage. So 0.5 is like half size, 50%. 200 would be, 200% would be like 2. Okay. So we've got those things, and then we can plug them in. So with the rectangles. Now again, why is this buggy? Like because we don't have the centroid for each thing, the center of scaling, and we can do that with the area. These are closed, so we can do this with the area component. Okay, and we can hide all this stuff. And so now we've got these things, and if I have a number slider, it's just a nice way to. So this is what they look like, and this is the scale. Right. So again, you can sort of go back to the things that we did before. If we wanted to scale this entire list of things, we could do something like a range. We could also go back to the graph mapper, as we kind of talked about. Remember, we have to think about the number of things that we have oftentimes, and so that's where we get the list length. And we can just take it from here, it's fine. And don't forget, we're gonna do x minus 1 because we have too many things. And you do the sine. I love sine waves. Never get tired of sine waves. Let's just see what the output is. So we've got all these different scales. And we have what? 121 things. Whew. All right, it's broken here. Oh, cannot scale with 0. Yeah, so we have to, this is the domain input. I just have to make sure that it's not, make sure it's not. So this would be from point 1 to 1. Go ahead and hide these. Right, and so this is where, ooh, get some pretty wacky kinds of things that you can design. It's pretty neat. So this is just controlling, the output of these curves here. So anyway, something to kind of play with it a little bit, just to say like, how do I get some different values? We'll look at some of this stuff a little bit later, how to make it a little bit more complex, but there's that kind of thing. I mean, the other thing that we've talked about is just simply taking the number of things and having them across a domain. So we can construct domain. Let's call it 0, 1, 2. Then I've got some room to play here, as long as I don't go down to 0. Okay, there we go. So that's how we would end up getting some of those different values for things. Uh, yeah. And it makes me realize something too, like just we can get into this later, but like this particular kind of grid started with things in these rows, and that's kind of affecting the way that this is. And you may be fine with that. Let me talk about another kind of grid really briefly here. So what you can do, so this grid again it's divided into rows, which could be useful for you. But what if you simply wanted something that works more the way you expect it to, where it would actually count back and forth, or would sort of count in a way, rather than restructuring that data, which is what we could do. Use a different structure. So you can go into surfaces, and I'm just going to do like a plane surface. And a plane surface is just like you can make a surface and you have dimensions in the X and Y. These are domains, so it works pretty similar to the way that the rectangle did, right? You have these domains. And this is why it's really important to mouse over and say what it wants, okay? But we're not going to worry about that for now. So we can do that, and we can, I'm pretty sure we can just divide. Yeah, so you get corner points, okay? Oh, shoot, and these things are in lists too. Ugh, I don't like that either. Is this going to do it too? Yep, it is. Boo. Well, I think the issue is maybe that these things are in like columns, and we kind of want them in rows, right? So I think this is probably gonna cause some problems. So I'm gonna get rid of these. So that's again just another way you can do it. One thing you can do if you want to change the rows and columns of things is you can do what's called a flip matrix. You can plug these in, and that'll change the rows to the columns, and that just gives you a different kind of ordering structure of the data. I'm gonna have to, yeah, this we're gonna have to do more with that later. But anyway, that's the way that stuff comes in. But that's a way that you can get things distributed to kind of a grid system. Points, are gonna, as we're gonna see, are really useful for that, for like placing objects on things. So that's when we can get things to points, and then you can transform those things at the points. Okay. So scale's pretty easy, as long as you just recognize that you need to get the center of scaling for something, and then that's how you can actually transform it correctly. and all the other kind of rules apply. Okay, so going back to these, so this is a grid distribution. Um, here you've got different series of lines that you're moving. There are multiple series components, right? At some point, you could probably take the entire thing that you made and like rotate it, right? So we can maybe kind of talk about that just really briefly. Um, let's just say like we talked about making an SDL line, right, as kind of a really easy way to make a line primitive. Remember, it wants a start point and a distance, direction and a length. In this case, we want the direction to be y, so we're going to use one of those unit y's. And the start point, is usually 0, 0, 0. We could do construct point. So now we got a line. And I'm just going to make these 10. I got a line right here. And we talked about moving them. So you can move them in the X. This goes back to, what we did before. Right? And so like if you wanted to rotate an entire group of things, you could actually, there's different ways you could do it, but one thing you could do is like put them into a group, right? So now he's got one kind of object. And then you can do what I did before with the bounding box. So now we've got the area centroid of the group, and then you could rotate the entire group of things. Make sure I've got this right. Oh, that was the wrong thing. Yeah, so you can do that. Remember, that's the bounding box. That's why it looks weird. So that kind of stuff works pretty well. So like if and then of course because of the wonders of parametrics or whatever, if you change things in it, or if you change the number of things, obviously, then you can get those kind of effects. So sometimes you want to like operate on the entire group at the same time, and even for things like scale or whatever. And so that's one way to do it, is to actually put them into groups. There's other we'll talk about other ways later, but that's another thing that you can do. And again, once you kind of have a centroid, you can also share that same centroid, and that can make things really useful too. So yeah, so there's lots of different. Let's even do a series. I don't know. Oh, or maybe a range, I guess. It's kind of playing here, but yeah. So there's different things you can do, again, by playing with a number of inputs. Playing with a number of different things. And I just messed around or whatever, but like you really have to be in control of what you're doing. Kind of understand like the principles of the effects that you're trying to like achieve and that sort of thing. But it does become pretty powerful pretty like quickly to stack these things up. So we have another example of move, rotate, scale. I'm gonna go ahead and make a new thing. So just to take this back to architecture, if you can believe it, some of the things we can do with these things. We saw some examples of some design stuff earlier on, like these kind of fields and like towers and things like that. And so I just want to kind of talk about that at the end. So I've got the kind of ground here, and I can start with maybe just something like a rectangle, like I've been doing, and I'll keep the default rectangle. And one thing that we do a lot, which we haven't talked about yet in Grasshopper, but we do this a lot in Rhino, is just extrude some things. You take a rectangle and you take a direction, and we usually do Z, right? So now we've got a rectangle, And to get a rectangle to be solid, we just cap it, and that's it. And we can do a lot of stuff though with transforms and start to make this into something that we can use, for like a massing or something like that. And so that would be something as easy as having, like a series, and we would go ahead and let's see, I would let's see. So you've got this is being that's the extrude, but what we want to do first is actually go back a step and move it in the Z. So we can say take a rectangle and we're going to move these rectangles up. Well, there's one rectangle. And then if we have a series, right, we're going to move these rectangles up. And let's just go from 0 to maybe 20. Uh, yeah. And then, so let's see, that's the number of, so now we have a number of plates, right? And then we could have a distance for those things. And so we could say, and you can make a decimal just by adding in the decimal at the end. And so now I've actually got the distance between them. You can see where I'm kind of going with this. So now I've got all these things. And then if I take all those things and I extrude them here, you can see that I've made them all some kind of number. But what happens is that if this distance is more than, than 1, right, then they don't, or if it's smaller, they get stuck together. So how do we make them dependent on one another? You plug the same value in for the extrude, and now you've got this kind of parametric thing. So you make a building. You have number of floors, and you have floor height. So that's an easy parametric kind of system. And then you can start to do things like with our transforms. Like I can take in the rotate, and I can start to rotate these things, right? So they're all, and let's get the area for each one. And let's get that in for the thing. And then we can take this angle in degrees, and we can do certain things. So we can go through and maybe with something like a range slider, as you're kind of seeing. Actually, let me borrow one of my friends from. Oh, well, hey, check this out. Um, you can actually go in to your other scripts that you've got, and I haven't been bad because I haven't been saving anything, and you won't do that because you are all scholars and smart. Um, Let me see. Where is my rotate? Yeah. Let's see here. Oh yeah. Yeah. I don't know. I guess I thought I had a whole thing built, but I guess I kind of messed it up. So I'll just copy it and then go into my new one here and paste it. So you can do that. You can go from one script to another. It's kind of cool. Okay. All right. So got my domain here and 0 to some number. And let's see. Oh, and I need that range. That's what I was missing. Now I don't need to worry about, if I have the number of steps, the number of things, I can plug it in here. And then I can just do my x minus 1. Um, the screen does weird stuff. It throws it in my other monitor, so just do x minus 1. Okay, and then plug that in for the angle. Oh no, now we got some architecture. Watch out, right? You can make this more subtle. You can also start it at a certain point. And then you can charge people millions of dollars for your fantastic architecture. Parametric, right? Really, and the rectangle is too. I'm lazy and I haven't even controlled it. You can control that too. But there is that thing. let's take it a step further, right? So we can do the scale. So centroid, our friendly center friend, take in our geometry, and you can hide this. Oh, that's a problem. Let's see here. So that's actually not, I don't want to scale it in the in the z direction. Maybe I can do a different kind of scale. Yeah, that's a problem. I mean, otherwise, what I could do is I could control the floor plates here, but I don't want to. I'm trying to talk about scale today. So, what kinds of scale things do I have? I could do non-uniform scale. Yeah. Okay. Plane, same deal. Base plane, centroid. Okay. Now what? Let's make a domain. Well, same thing. Excuse me. But then for the domain, I'm gonna put a new construct domain. I thought that was gonna be naked, but it's got connections to those other ones. Construct domain. Ah, darn it. Oh, yeah, these little things on the bottom too. There's this little thing that's kind of like a predictive filter or whatever, and in this case, it's right. It just analyzes like how often you use certain commands. Well, there's the construct domain thing. Oh, I lost it. Oh yeah, it just popped out. There we go. Fun. Neat. Well, that worked. So otherwise, you can find construct domain under math. And you just grab it. Probably should have done that. It's faster. Construct domain's a lot to type. So now we can actually control the scale in the x, y, and the z. And so instead of worrying about the z, we can just scale it. And also, we never want to scale starting at 0. Um, so let's just do. Now you want to make these that much smaller. I might do like 0.9 to I don't know, 2 or something. Oh, that's not what I wanted. There we go. Anyway, let's plug those in because at 0.9 will just be smaller, slightly, but it won't be like teeny tiny. Yeah, so there we go. Okay, let's hide this. And so now at this end of things, we can sort of dynamically scale as we go, which is kind of neat. Let's make this bigger. That's pretty cool, but we can even do better. So just to all that is to say, you know, you're only controlling the scale of each object in the one axis. You could also control it in the other, but what we don't want to touch is that z because that's where we lose our floor plates. Um, I mean, yeah. So that would really be controlled back when we extruded it and moved it. If you scale it here, you're just going to lose space between them. So you got to watch that. But you'll figure that out. So yeah, I don't know. We do something fun. Let's just make a graph mapper. So you know you've seen this before, but we'll do the construct domain over here. Yes, and we'll do no range. What am I talking about? The range in and the construct domain blank. But we'll start with some low number. Okay, still plugged into the number of steps we have. Then we'll plug this in for the x. Okay, now I'm not really seeing anything. But if we go into the graph types here, now it got it got teeny tiny again, and so that's where we'd actually really got we need a multiplier, and we just take the input, and we'll take some value. I'm liking that today. Now it's gonna get huge, but we can control that. And the bottom value seems pretty low, so I might need to control that as well. There we go. So maybe this needs to be closer. Starting value needs to be closer to 1, and then that goes to 1. Anyway, so you can kind of play with this dynamically. But if you do some things with the graph mapper, we can control some of this stuff. And I might be overdoing it a bit. But we can kind of play with it. So like by adjusting the height and stuff too, you don't have to it doesn't have to be quite so wobbly. The other things you can do with it, would be just to simply, you can do some stuff with like the Bezier. So you can have it, you have more control over it when it goes in and goes out and so forth. It's kind of subtle, actually. If that makes sense, but yeah, so you can kind of control that. These get kind of fun. Um, these kind of experiment with them a little bit. Let's see here. I like parabolas too. So if you can kind of get right parabola. Yeah, that's not what I was thinking. Let's see here. Yeah, anyway, so there's some things you can play with. And these just become more graphical. That's kind of instead of having to figure out like the actual math there, that's what I was thinking about. It's kind of Gaussian. You can get that kind of tower kind of effect that you wanted. Right. Anyway, so and if the math is not working for you, that's where you really want to go look at a panel and say, well, like what am I starting with? What am I ending up with? In these sorts of things. And I think that's where you can kind of help yourself out and see how small this is actually getting. As it kind of heads towards the top. And how large it is at the bottom. And so that's where you have to go in and say like, okay, well, do I need to change these values? You know, ooh, it's kind of fun. Like I said during class, you'll get the hang of it. It gets a lot more intuitive as you go. But anyway, hope that gives you a start to kind of understand how these things can kind of stack together. And we've just started, so don't worry about kind of getting everything. But you've seen a lot of patterns that I've used, and I hope that stuff sticks. And you've seen a lot of different components, and so I hope those are also some things that you've kind of noticed. If we go back to our original scripts, and you'll see a lot of times, so finding the center of things, range with construct domain, saw series components, being used. We know how the computer expects to handle the rotate and the scale. We've looked at how to use the list length to make sure that we have the right number of objects. We've talked about controlling, the number here with a little bit of math, a little bit of expression. There's a series right here. Um, Combining, these things together, right? So we've got move, rotate, scale. So that should get you a lot of, so that last thing I showed you, if you had a lot of control over it, you really could end up with this, if you practiced. But a lot of these go back down to composition. Like, it's not just about the technology and about, using the right components or whatever, but it's about like what's the object you're making, like what's the transform you're making, how does it like align itself graphically. what's the meaning of the thing, right? Um, so there's some things. This is very similar to the thing we did for the tower, only the height or the transform of each thing is changing as you move it. So there's probably some kind of a range, and that could even be a graph mapper, right? So it starts off as a very small kind of thing, and then it gradually gets larger. Um, graph mapper is good because you can do things that are not just um, like adding something to something else. Like you can actually do transformations that are. I'm trying to get my drawing tool here. I'm using an old version of maybe a comment. Here we go. Yeah, like you can use transformations that are logarithmic, right? And so like that's what this is. Like these scales are very, very small, but then they end up getting exponentially larger. So that's where the graph mapper helps. Same thing with this kind of thing. Ditto. I think we know how to do these. So we showed that. Here's these scale and rotate. There's another example of scaling and rotating. Here's a grid with slight rotations. Same deal. So, these we would probably group and then distribute, right? Good. So anyway, I think that covers pretty much every example that we've had. Just take your time and think your way through them and like think about some of the examples and do what you're comfortable with, but don't worry about like learning or mastering every single thing. This is only like really early into Grasshopper. But I hope you can see how like it relies upon different kinds of patterns of things and different habits of thought, about the way that you structure things you make. But there's a lot of potential, and there's a lot of people to help, and yeah, all right, okay. So we'll end there, but don't forget there's a pinup, and don't forget to use the links in the comments to jump to different parts of the video if you're looking at for a particular thing. That's going to help you a lot. All right, I'll see you in class.